All right, welcome to the Integrated Math 3 final review. Let's begin. So it says, consider the figure given below. If the square is rotated about line L, so that means it's going to rotate around like this. Something like that. It's rotating around line L. What will the figure be, the solid object that's formed? So it's rotating like this. And so the solid object, well, look, it says it's a cylinder. Now, let's not bank on them giving us that on the test, though. But can you see that it's going to form a cylinder? Right, so it will be a cylinder. It will have a height of 3 units and a radius of 3 units. And so it says that it will be a cylinder with a radius of 3 units. That is true. So we're going to select box A. The object is a cylinder with a radius of 6 units. That is not true. That's the diameter. It's a cylinder with a diameter of 3 units. Nope, that's the radius. It's a cylinder with a height of 3 units. Yes, that is true. And it is a cylinder with a height of 6 units. That is not true. And you see that your 3 choices were cube, cylinder, or cone. And then based off of the rest of the problem, hopefully we know what they're talking about, that it's got to be a cylinder. Okay, next one. Frank the farmer has a variety of weather vanes that sit atop his barns and silos. So a weather vane, if you don't know what that is, like if you have a roof on a house, a weather vane, it's like a little, usually they have like a chicken or something on top, and these 4 little, so it stands like this, and these like 2 little bars that go out, and it spins and points like north, east, south, west, so it spins around. So this is another rotation problem. All right, it says he has a variety of weather vanes that sit atop his barns and silos. They're nothing fancy, simply a 2-dimensional object attached to a vertical pole. Where Frank sits at, it tends to get very windy and blustery, making the wind direction swirl and shift rapidly. On some day, the weather vanes spin around so quickly that Frank can catch a glimpse of what it looks like as a 3-dimensional solid. I don't know if you've ever watched something spin like that, but you can like see if it spins really quick. Like if you wind something up on a rope and let it go, you can almost see that 3-dimensional solid. It says match each of the 3 weather vanes to the solid that it would create. Okay, so our choices. So we have this weather vane, and it's going to spin this direction, right? Because it's spinning with the wind, spinning round and round. And so this, when it spins, at the bottom, it's going to be wider, and at the top, it's going to be like super narrow. So it's going to form a cone. And so that would be right here. So number 1 is a cone. Okay, the next one, when this one spins around and around, the same thing, right? It's spinning this direction. And so it's going to form a cylinder. Now, when this thing spins, it's going to spin like this, right? So at the top and at the bottom, it's going to be wider. And right here at the base, it's going to be really narrow. I shouldn't say at the base. At the joint, it's going to be really narrow. It's going to kind of look like an hourglass. Right? So this guy right here, and I'm going to call that an hourglass, but you could call it like a cone on top of a cone. And then this one, when it rotates at the top, it doesn't do much. In the middle, right, you can kind of see it's going to be wider, and then here, and so on, and so on, and it's narrowing and narrowing and narrowing, and so it's going to be a sphere. And that would be this guy, a sphere. All right, next question. So it says that, I'm going to just make sure that you guys can see all of those, right? A sphere, an hourglass, a cylinder, and a cone. All right, next. It says, given that the function g of x is log base 2 x minus 3 minus 5, identify all the following points that would fall on its graph. So one way you could do that is to substitute these values in. All right. Another thing that would help you here is that this number cannot be negative. So if you start substituting these values in, like for x, you substitute in -1, you're going to get g of -1 equals log base 2, -1 minus 3 minus 5, and that would be log base 2, -4 minus 5, and you can stop right there. This number cannot be a negative. And so you're going to get rid of any values that will make this a negative value. That's just a definition of a log. And the reason is because 2 to no power, right? Like 2 to nothing. There's no power I could put here that will give me like a -4. Nothing. If I put -2 here, nope. It's not -2, right? 2 to the -2 is not -4. 2 to the -2 is 1/4. Okay, so that number can't be negative. So again, get rid of those. All right, so this one might work because 3.5 minus 3 is 1/2. So this might work. This one will not work. If I put in a +1 right here and I subtract 3, I'll have -2, so I can get rid of that one. If I put in 2 right here, I'll have a -1, so that one won't work. So those 3 just get rid of right away because they're going to make this parenthesis portion negative, and that can't happen. Okay, so we're going to check the remaining 3. So g of 3.5 is equal to log base 2, 3.5 minus 3 minus 5. And so that's going to be log base 2 of 1/2 minus 5. And right, this should equal -6 if we've done it correctly. And so I'm going to check, does this equal -6? Right, so 3.5 for x and -6 for f of x or g of x. So -6, and then so this right here, I'm evaluating this. Log base 2 of 1/2. So I'm saying 2 to what power is 1/2, which is -1, right? So this value is -1. So -1 minus 5 is equal to -6. That is true. So B will work. All right, I'll do the next one, 5. So g of g of 5 is equal to log base 2, 5 minus 3, and then minus 5. And remember, I'm checking to see if this will equal -4. So -4 is equal to log base 2, that would be 2 minus 5. Now I'm going to evaluate this portion off to the side. Log base 2 of 2. So they're saying 2 to what power is equal to this 2? And that would be 2 to the first. And so this whole thing is 1. So -4 is equal to 1 minus 5, and that is true as well. And then finally, the last one, so this one is correct. Let me circle it. The last one is 4. So g of 4, log base 2, 4 minus 3 minus 5. And so they're saying this should equal -5. So -5 is equal to log base 2, that would be 1 minus 5. And then off to the side, log, I'm evaluating this, log base 2 of 1. So they're saying 2 to what power is equal to 1? And it's 2 to the 0 power. So this is 0. So -5 is equal to 0 minus 5, and that is true as well. So all 3 of those were correct. All right, next one. Place the correct value with the correct trig function. Oh my. Okay, now on this one, when you're doing this one, because it's a drop and drag, and there's more than one correct answer, so I'm talking about like right here, there's more than one, I shouldn't say correct answer, there's more than one, for example, √3/2. Okay, like there's a √3/2 here, and a √3/2 here. Now, if you drag this √3/2 to the one that the person who created this problem didn't match it with, it's going to mark it wrong. But if you had dragged this one, it would have marked it right. So don't worry about it. As long as if it got marked wrong, as long as you have the correct value, you're correct. Okay. Now, you are allowed to use your unit circle. Why on earth, if I'm allowed to use my unit circle, and all of these you should recognize are on the unit circle, why on earth would I not use my unit circle? So I'm going to use my unit circle. Okay, sine. Well, we do have to know this, right? Sine is your y values, and cosine is your x value, okay? There is no tangent on here, so you don't need to worry about tangent for this question. Okay, so let's go ahead and on our unit circle, see, right? Sine is y, cosine is x. So we're going to find sine, or the y value, of 5 pi over 3. So 5 pi over 3, 5 pi over 3 is right here. The y value is negative square root 3 over 2. So negative root 3 over 2. I'm going to continue to do this. Cosine is x, and we're looking at 2 pi over 3. 2 pi over 3, the x value is negative 1/2. Sine 3 pi over 4, so 3 pi over 4 is right here. Sine is the y value, square root 2 over 2. 7 pi over 6, I'm not going to continue to show it on my screen, but 7 pi over 6, I'm using my trig table, or sorry, my unit circle. So 7 pi over 6, and I'm doing cosine. Cosine is the x value. This is negative square root 3 over 2. 5 pi over 6, sine is 1/2. 5 pi over 4, sine is negative square root 2 over 2. 7 pi over 4, cosine. Cosine is square root 2 over 2. 2 pi over 3, sine is square root 3 over 2. Sine 3 pi over 2. 3 pi over 2 sine is negative 1. Cosine pi over 2. Pi over 2 is 0 for cosine. 7 pi over 4. 7 pi over 4. And I'm doing sine. Sine is negative square root 2 over 2. And cosine 5 pi over 3. 5 pi over 3. Cosine is 1/2. Cosine 11 pi over 6. That's square root 3 over 2. Cosine pi over 4. Cosine pi over 4 is square root 2 over 2. And sine 7 pi over 6 is negative 1/2. And that's it. Those all came from my unit circle. And you are allowed to use your unit circle or print one out. Okay, moving on. So that was the next 2 pages, actually. At the very bottom, there is another question. Find an equation in vertex form for the parabola with a focus at 1, 4 and a directrix at x equals 5. Okay, so I'm going to sketch this guy. I'm actually going to use this room up here that I have. So I've got my focus and my directrix. So my focus is like this. It's like on a satellite dish. It's like the little receiver in the center, right? And the directrix is an invisible line that's equidistant from the vertex and the directrix. The distance will be the same from the vertex to the directrix as it is from the directrix to the focus. So I'm going to sketch these 2 things. This is a point 1, 4. 1, 4. My focus, F, is right there. My directrix is at 5. 1, 2, 3, 4, 5. So, and it's a like invisible line. And what happens is the vertex is in between these. So the vertex is in between 1 and 5, which would be at 3. So the vertex is right here at 3, 4. And it must be opening like this direction, right? Because it's got to contain the focus, like a satellite dish would contain the receiver. All right, so then we do need to know one little formula. Well, of course, you should know y equals ax minus h squared plus k, right? So that you should definitely know. But you also need to know this one little formula, which is that a is equal to 1 over 4p, where p is the distance from V to F. Now, in this case, It's opening to the left. And so you notice that P is this distance from V to F is -2. And so in this case, P is -1, 2 units, right? -2. And so that means that my A value will be 1/4 times -2, which is -8, or -1/8. And then H and K were given to you. Well, not really, but I mean, they are. They're H and K is the vertex, right, which is right in between the focus and the directrix. So it's going to be at 3, 4. So the vertex is at 3, 4. Again, right in between these two. And so this would be y equals A. A was -1/8. And then x minus h is 3, squared, plus k is 4. All right, so you must know this. You need to know the vertex is in between the focus and the directrix. And I always sketch myself a little picture. They're going to ask us for the same thing again on the next one. It says find the equation of the parabola with focus at 0, 1. So I'm going to sketch that. My focus is at 0, 1. There's F. And my directrix is y equals -1. So y equals -1 is right here. And so it's going to go this way. This time, right, again, the vertex is right in between these. So the vertex is right in between these, right there. And so this guy's opening upward because the focus has to lie inside of it. So there's my vertex. So my vertex is actually at 0, 0. That's kind of nice, right? All I need to do is find my A value. And remember, A is 1/4P, where P is the distance from the focus to the vertex. And this time it's +1 because it's up 1. So 1/4. So P was 1. All right, so that would be 1/4, and then x minus h squared plus k. There's really no need to fill these in. Zeros, it's the same thing, so this is 1/4 x squared. Okay, next one. Consider the pair of functions given in the first column and determine if the second one is the inverse of the first. Oh, sorry, if they're not the inverse, if they're equivalent. All right, so actually they accidentally did pair 4 for you, but I'm going to go ahead and do it as well, just so that we know. All right, so they've given it to us in what's called exponential form and in log form. And so I actually like to work with log form. X equals log base 2y. Remember, we're doing that hook method where we go 2 to the x is equal to y. 2 to the x is equal to y. And that is what they have, so I'm going to say yes, they're equal. Again, I want to work with my log form. X is equal to log base 2 of y. And so this time it would be 2 to the x, same thing, right, is equal to y. So that is not what they have here in exponential form. So this is not equal. Again, working with exponential or log form, x equals log base 4y. So hopefully you can start to see the pattern. 4 to the y, or sorry, 4 to the x is equal to y. And that is true, that's what they have. So I'm going to say yes. And the last one, x is equal to log base 6y. So this would be 6 to the x is equal to y, and that is not what they have, so that is why they had a no. All right, so hopefully those are pretty easy. That's just the definition of a log, or what I say, use the hook method. All right, solving this equation. So they're both in base 5, right? And there's an addition symbol. So the way I like to solve these is, since there's an addition symbol, I'm going to rewrite this. It's log base b of m plus log base b of n is equal to log base b m times n. All right, so we're going to multiply these two and write it in one log. It's called condensing a log. So I'm going to multiply these two together and write it in one log. So this is going to be log base 5, right, because the base was 5, and then it's x times x plus 4, right? M times n. So this is log base 5 distribute x squared plus 4x. Okay, so that's my step 1. So I'm rewriting this left-hand side as log base 5 x squared plus 4x is equal to, and then the right-hand side I didn't do anything, 1. Right, now to solve a log, we have to get this out of log form. So I'm going to raise both sides to the 5, or base of 5. So these will cancel, and I get x squared plus 4x is equal to 5 to the first, which is 5. And now it's a quadratic. So to solve a quadratic, we're going to move everything over and either factor it or use the quadratic formula. So I have x squared plus 4x minus 5 equals 0. It does factor. This factors as x, well, what will multiply to negative 5 and sum to positive 4, which is 5 times negative 1 and 5 plus negative 1. So I've got x plus 5 and then x minus 1 equals 0. Set each one equal to 0, x equals negative 5 and x equals 1. Now, you notice it says which is the solution. There's only one that's a solution, and I'll go back to what I said it was one of the first problems. This value cannot be negative, right? The value inside the log right here, nothing will, 5 to no power will give me a negative here. And so I noticed that if I substitute in negative 5, this would be a negative, and this would also be negative. And so negative 5 is what's called the extraneous solution. And 1 is the good solution. So x equals 1 is my good solution, and x equals negative 5 is my extraneous. And you should always check these. If you substitute in 1 right here, you're going to get log base 5, 1 plus 4 is 5, plus log base 5 of 1, and that should equal 1. When I check this, 5 to what power is 5? That's 1. 5 to what power is 1? 0. And 1 plus 0 is 1. All right, next one. Let me check the time. Oh, we're good. So whenever you're missing more than one angle or more than one side of a right triangle, so you have a right triangle and you're missing either two angles or two sides, you're going to use trig. So, toa. All right, and I am missing both angles, so I'm going to have to use trig. First, identify your hypotenuse. It's right here across from your right angle. I'm using angle X, and so adjacent would be this side. This is my adjacent. And so since I'm going to be working with adjacent and hypotenuse, I would use adjacent hypotenuse cosine. So I'm going to get rid of these. My function would be cosine of the angle is equal to adjacent over hypotenuse. And then to solve this, I would cosine inverse both sides. So I get x equals cosine inverse 3 over 25. And so that would be A. Number 10. A unicyclist cycles his bike across a stage. The stage is 50 feet. So that means that from the bottom of his wheel, right, when it goes all the way around, he has traveled 50 feet. So the circumference, C, is 50. The circumference of the wheel. And the diameter has the wheel has a diameter of 3. And he rides, like I said, 50 feet. And it says, what is the angle in radians that the wheel turned? Round to the nearest whole number. And so what we're doing is we're using the, that S, the length traveled, is equal to theta, not sigma, not in stats right now, theta times R, the radius. And S is the length traveled, which is also known as the circumference. So 50 is equal to theta times r, the radius. The radius is half the diameter. The diameter is 3, the radius is 1.5. And so we'll divide both sides by 1.5, and 50 divided by 1.5 is 33.3. But it does say to the nearest whole number, so 33 radians. Or 360 degrees. Right, 360. Let me just check that really quick. Now watch, I'm wrong. No, it has to be 360, but if we were to change 33.3 into degrees, we would multiply by 180 over pi. So 180 times 33.3 and then divided by pi. No, that doesn't work. I don't know what I did. It doesn't matter. Okay, moving on. So just ignore this. Okay, next. Oh, because it probably, I know why, because he went more than one circumference, right? But, so he went several circumferences, the length that he traveled, that's why. Okay, so match the function f of x with its inverse function. I mean, really, you can just kind of see, all right, this has got a 4 and a 5 in it. This one has a 4 and a 5. They must go together. A 2 and a 10 and a 6 and an 8. But I'm going to do them because it might be that on the test, they give you like all 6s and 8s or something. So to find the inverse, right, I know Miss Baena says, well, solve for x and then switch x with y. You could do that or solve for switch x with y and then solve for y. It's up to you. So I'm going to do it the way I've always done it. So the first one, I'm going to rewrite it with a y. Then I'm going to switch x and y. And then I'll solve for y. So it's subtract 8 and then divide by 6. So we get that f inverse x is x minus 8 over 6, which must be this guy. So these two match. The next one, y equals 2x minus 10, switch x with y, x equals 2y minus 10, solve for y, x plus 10 equals 2y, and then divide by 2, so x plus 10 over 2. And so you can see that one's right here, the third one. And then the last one, x plus 5 over 4 is equal to y, switch x with y, x is equal to y plus 5 over 4, multiply both sides by 4. So I get 4x is equal to y plus 5, subtract 5 from each side, 4x minus 5 is equal to y. And so that would be this guy right there. All right, the next one, it says to solve algebraically. So when we have a square root and another value, we want to move this value to the other side first before we start. So I'm going to move that value over. Then I'm going to square both sides because my goal, remember, is to get x by itself, but I can't do that if it's under a radical. So these will reduce, and I get x plus 2 is equal to x squared. And now since it's quadratic, I want to move everything to one side and get this side equal to 0. So I'll subtract the x over and subtract the 2. 0 equals x squared minus x minus 2. And then at this point, it's probably factorable. And so I would factor something that multiplies to negative 2, but adds to negative 1, which would be negative 2 times 1, and negative 2 plus 1 is negative 1. So 0 equals x minus 2, x plus 1. Set these equal to 0, we get x equals 2, x equals negative 1. Now, we're going to check them both because it could be that we have an extraneous solution. So we're going to substitute both values back into your original problem. So I have square root, I'm going to do 2 first, right? So 2 plus 2 and then plus x, which is 2, equals 0. So square root 4 plus 2 equals 0. And when I add 2 plus 2, last time I checked, I do not get 0. And so this is an extraneous solution. The other value, -1, so square root -1 plus 2 plus -1 equals 0. This would be square root 1 minus 1 equals 0. Square root 1 is 1. 1 minus 1 equals 0. Check. So this is my good solution. Now, it's not always that you get two good solutions, so you do need to check both. All right, next one. So they've taken a square root function, and by the way, the parent is y equals square root x. And so in this case, it's easier to plug in values for x and see what you'd get for y. So like, for example, if I plug in 4, I'll get 2. If I plug in 1, I'll get 1. If I plug in 0, I get 0. So 0, 0, 1, 1, 4, 2, 9, 3, and so on. Here's your parent. And all I did was plug in values for x, like 0, 1, 4, and 9. And then I square rooted those values, 0, 1, 2, 3, and got these values for y. And so what has happened is that this graph has been shifted up 1, 2 units. So k is 2. And to the left, 1, 2, 3, 4, 5 units, so h is -5. And so in our parent, we have y equals a, x minus h, square root x minus h squared, not squared, x minus h plus k. And our a value actually didn't change. You can see that this point is where it should be from the 0, 0, and then up 1 over 1, and then up 2 over 4, and so on right there. Up 3 over 9, and so on. So there's no a, or a is 1. Okay, so all of these though had an a value of 1, so it didn't really matter, but I wanted to point that out in case there is a stretch on the final. So h shifts to the left 5, so that should be a plus 5 under the radical, and it shifts up 2, so that should be a positive 2 outside, so it's going to be b. Again, h is -5, so that becomes positive 5, and k is positive 2. So 5 and 2. Which of the following cube root functions is not one-to-one? Okay, so just to remind you of what one-to-one means, one-to-one means that it'll pass both a horizontal and vertical line test. So for example, a cube root function would look something like this, and it'll pass both, it shouldn't be going downward at all, it'll pass both the vertical and horizontal line test. It'll only pass through once, it'll only pass through once, and so on and so forth. So most cube root functions are one-to-one, but if you do something funky, like put a squared underneath the cube root, then it might make it not one-to-one. So in fact, this will be some kind of a horizontal or vertical stretch, and this will be a horizontal shift. This, you're just changing your a value, right? So you're multiplying by like a third.